Hello viewers, welcome to the Bachelor's course of Population Studies. Today we will discuss about the methods of population analysis. Analyzing information involves examining it in ways that reveal the relationships, patterns, trends, etc. that can be found within it. That may mean subjecting it to statistical operations that can tell you not only what kind of relationship seems to exist among variables, but also to what level you can trust the answers you are getting. Data can be broadly divided into two types: quantitative and qualitative data. Quantitative data refers to the information that is collected as or can be translated into numbers, which can then be displayed and analyzed mathematically. Qualitative data are collected as descriptions, anecdotes, opinions, quotes, interpretations, etc., and are generally either not able to be reduced to numbers or are considered more valuable or informative. Quantitative and qualitative information needs to be analyzed differently. There are four types of population analysis. These can be descriptive analysis. The simplest form of data analysis is the descriptive analysis. It lists and summarizes the values of each variable in a data set. Second can be exploratory analysis. Once you understand the data you have, the next step is to start looking for relationships among the data elements. That is, to explore the relationships. This is called exploratory data analysis, and it typically focuses on correlations among variables. The third type of analysis is inferential analysis. It is concerned with the various tests of significance for testing hypotheses in order to determine with what validity data can be said to indicate some conclusions. The fourth is predictive analysis. It is a very popular method in business intelligence applications. The objective is to use data you have to predict an unknown outcome and then to take action based on that prediction. The important statistical measures used for the analysis of data research can be discussed like this. The 5 important statistical measures used for data analysis of research are measures of central tendency, measures of dispersion, measures of skewness, measures of relationship, and other measures. Let's discuss these measures one by one. Measures of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. As such, measures of central tendency are sometimes called measures of central location. The mean, median, and mode are all valid measures of central tendency. But under different conditions, some measures of central tendency become more appropriate to use than others. In the following sections, we will look at the mean, mode, and median and learn how to calculate them and under what conditions they are most appropriate to be used. The first one, mean, or what you call arithmetic mean. The mean or average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean is equal to the sum of all the values in the data set divided by the number of values in the data set. So, if we have n values in a data set and they have values x1, x2 up to xn, the sample mean will be usually denoted by x bar. The formula is usually written in a slightly different manner using Greek capital letter sigma, or you call sum of. One of the important properties of mean that it minimizes error in the prediction of any one value in your data set. In addition, mean is the only measure of central tendency where the sum of deviations of each value from the mean is always 0. But this method has certain limitations. Number one, it's unduly affected by extreme items, that is, the outliers. If the data becomes skewed, the mean loses its ability to provide the best central location for the data. Seeing these limitations, we have another method called median. The median is the middle score for a set of data that has been arranged in order of magnitude. The median is less affected by outliers and skewed data. In order to calculate the median, suppose we have the data as shown on the screen. We first need to rearrange the data into order of magnitude, starting with the smallest first. Our median mark is the middle mark. In this case, 56, as highlighted in bold, is the median value. Disadvantages of the median. It's a positional average. It is used only in the context of, say, qualitative phenomena. It is useful where items need to be assigned relative importance and weights. It's not frequently used in sampling techniques. Then we have mode. Mode is the most frequent score occurring in our data set. On a histogram, it represents the highest bar in a bar chart or histogram. You can therefore sometimes consider the mode as being the most popular option. Normally, the mode is used for categorical data, where we wish to know which is the most common category. However, one of the problems with mode is that it is not unique. So, it leaves us with a problem when we have two or more values that share the highest frequency. Here, the series is a bimodal series and we measure mode with the help of median and mean. Mode is also with some of its limitations. Number one, it's not amenable to algebraic treatment as the mean was, and sometimes remains indeterminate when we have two or more modal values in a series. Secondly, it's considered unsuitable in cases where we want to give relative importance to items under consideration. Let's summarize what we have discussed in the measures of central tendency and see when to use mean, median and mode. For this, you can look at the screen to find what the best measure of central tendency is with respect to the different types of variable. For nominal data, we use mode. For ordinal, we use median. Interval ratio, which is not skewed, mean. Interval ratio, which is skewed, we use median. The second measure of analysis is measures of dispersion. The dispersion is the tendency of data to be scattered over a range. Dispersion is an important feature of a frequency distribution. It's also called spread or variation. Range, variance and standard deviation are all measures of dispersion. Common measures of dispersion are range, inter-quartile range, quartile deviation, standard deviation, etc. Degree of dispersion. Measure of dispersion is useful in comparing two or more distributions in respect of disparities. A greater degree of dispersion means lack of uniformity or homogeneity in the data, while a low degree of dispersion stands for uniformity or homogeneity. Dispersion measures how the various elements behave with regards to some sort of central tendency, usually the mean. The main measures of dispersion are range, inter-quartile range, mean absolute deviation, variance and standard deviation. Also we measure coefficient of variation. Let's start with range. Range is the simplest measure of dispersion. It is the difference between the largest and the smallest value. Range is equal to largest value minus smallest value of the data. For example, if the lowest and highest marks scored in a test are 15 and 95 respectively, the range would be 95 minus 15, that is 80. Even though the range is the easiest measure of dispersion to calculate, it is not considered a good measure of dispersion, as it does not utilize the other information related to the spread. The second measure of dispersion is inter-quartile range, which is not affected by the outliers of the data, but nevertheless conveys the idea of range. It measures the spread of the middle 50% of an ordered data set. In other words, it is the numerical difference between the first and the third quartiles. Inter-quartile range is third quartile minus first quartile, that is Q3 minus Q1. Then we have mean absolute deviation. This measure of dispersion is the average of absolute deviations of data values from the mean. It is computed using the formula as shown on the screen, where x bar is the arithmetic mean of the data set. So what does this measure of dispersion tell about spread? A data set with larger mean absolute difference is more spread when compared to a data set with a smaller mean absolute difference. The mean absolute difference is sensitive to the outliers. Then we have variance and standard deviation. Variance, as the name suggests, it's a measure of how different the elements in a given population are. Variance is used to indicate how spread out these elements is from the mean of the population. There are two kinds of variances: population variance and sample variance. Population variance is the variance of the entire population and is denoted by S2, while sample variance is the variance of a sample space of the population and it is denoted by capital S2. Standard deviation is the square root of variance. It is the measure of how precise the mean of a population or sample is. It is used to indicate trends in the elements in a given data set with respect to mean, that is, the spread of these elements from the mean. Just as we have a population and sample variance, We also have a population and sample standard deviation. Population standard deviation is denoted by S, small s, while the sample standard deviation is denoted by capital S. Variance and standard deviation are better measures because of the way they are calculated. The population variance can be calculated as shown on the screen, where mu is the population mean. The sample variance is given by the formula where x bar is the sample mean. Standard deviation is simply the square root or the under root of the variance. So, we can calculate it by taking the square root of the above variance formula. Population standard deviation. The formula for this is shown on the screen, where mu is the population mean, and sample standard deviation where x bar is the sample mean. The difference in calculation of population and sample variance is the average if found using the number of elements in a set of 4. By contrast, we use 1 less than the sample space size for the population. The reason for this is that by using n-1, we ensure that S2 is an unbiased estimator of small s2. We have coefficients of dispersion. Why do we measure the coefficients? The measure of dispersion gives us an idea about the scattering of the values in the data about the average. The range, mean deviation and standard deviation are the 3 important measures of dispersion. The coefficient of dispersion is a pure number independent of the units of the measurement. For any data, it is always desirable that the measure of dispersion is less. The small value for the measure means that the values in the data are more consistent, centering on their average. The fourth method of data analysis is measure of skewness. The first thing you usually notice about a distribution's shape is whether it has one mode, that is one peak, or more than one peaks. If it is a unimodal, has just one peak, or it is symmetric or skewed to one side. If the bulk of the data is at the left side and the right tail is longer, we say that the distribution is skewed right or positively skewed. If the peak is towards the right and the left tail is longer, we say that the distribution is skewed left or negatively skewed. One measure of skewness is Karl Pearson's coefficient of skewness, which is measured as Karl Pearson coefficient of skewness Sk is equal to 3 mean minus median divided by standard deviation. If the skewness comes out to be 0, then the frequency distribution is normal and symmetrical. There is no skewness. If the skewness is more than 0, then the frequency distribution is positively skewed, and if it is less than 0, then the frequency distribution is negatively skewed. Other measures of analysis are the measures of relationship. Correlation coefficients are the measures of degree of relationship between two or more than two variables. When we talk about a relationship, we are talking about the manner in which the variables tend to vary together. For example, if one variable tends to increase at the same time the other variable also increases, we would say there is a positive correlation between the two variables. A relationship between two variables does not necessarily mean that one variable causes the other. I emphasize on this point. Scatter plots and linear relationships can be shown with the help of correlation. These are helpful ways to visualize a relationship between two variables, and it is to construct a scatter plot which you will briefly be introduced in the discussion of graphical techniques. A scatter plot represents each set of paired scores on two-dimensional graphs, that is x-axis and y-axis, in which the dimensions are defined by the variables. For example, if we wanted to create a scatter plot of our sample of 100 children for the variables of, let's say, height and weight, we would start by drawing the x and y axis, labeling one as height and the other as weight, and making of the scales so that the range of these axes is sufficient to handle the range of scores in our sample. Then we have Pearson's product movement correlation. The Pearson product movement correlation was devised by Karl Pearson in 1895, and it is still the most widely used correlation coefficient. The Pearson product movement correlation is an index of the degree of linear relationship between two variables that are both measured on at least an ordinal scale of measurement. The index is structured so that a correlation of 0 means that there is no linear relationship. A correlation of 1 plus 1 means that there is a perfect positive relationship, and a correlation coefficient of -1 means that there is a perfect negative relationship. As you move from 0 to either end in the scale, the strength of relationship may be positive or negative will increase. Under correlation only, we have another method which is called Spearman's rank order correlation. The Spearman's rank order correlation provides an index of the degree of linear relationship between two variables that are both measured on at least an ordinal scale of measurement. If one of the variables is on an ordinal scale, the other is on the interval or ratio scale, it is always possible to convert the interval or ratio scale to an ordinal scale. The Spearman's correlation has the same range as the Pearson's correlation, and the numbers mean the same thing. The formula for computing the correlation is shown on the screen. The one term in the formula that you might not be familiar with is small d, which is equal to the difference in the ranks of the two variables. Let us discuss the Karl Pearson's product movement correlation coefficient. It is the ratio between the covariance between two variables to the product of their standard deviations as shown in the formula on the screen. Now, what is covariance? When n pair of observations, let us say from x1, y1 are given between two variables x and y, then the covariance of x and y, that is cov x and y, is defined as shown on the screen. Other than correlation methods, we measure relations with the help of regression analysis. The most commonly used form of regression is the linear regression, and the most common type of linear regression is called ordinary least square regression. Linear regression uses the value from an existing data set consisting of measurements of the values of two variables x and y to develop a model that is useful for predicting the value of the dependent variable, say y, for the given values of independent variable x. The regression equation is expressed as follows: y is equal to a plus bx, where y is the dependent variable which depends upon x, x is an independent variable, a is the intercept, and b is the regression coefficient. We can also measure relationship between more than two variables with the help of multiple correlation. The simple multiple correlation coefficient, capital R, is a measure of the strength of the association between the independent explanatory variable, and the one dependent, that is the predictor variable. Interpretation of R. Strength of association. The strength of association is measured by the multiple correlation coefficient R. R can be any value from 0 to 1. The closer R is to 1, the stronger the linear association is. If R equals to 0, then there is no linear association between the dependent variable and the independent variables. Unlike the simple correlation coefficient small r, which tells both the strength and the direction of the association, capital R, that is multiple correlation coefficient, tells only the strength of the association. R is never a negative value. Formula for R. Formula for two independent variables x1 and x2 is shown on the screen. Multiple regression. It's a flexible method of data analysis that may be appropriate whenever a quantitative variable, the dependent or criteria variable, is to be examined in relationship to more than one factors expressed as independent or predictor variables. Multiple regression models and significant tests. Many practical questions involve the relationship between a dependent or criteria variable of interest, let us say y variable, and a set of k independent variables or potential predictors variables, let us say x1, x2 and so on up to xk, where the scores on all variables are measured for n cases. For example, you might be interested in predicting performance on job using information on years of experience, performance in the training program, and the performance on an aptitude test. A multiple regression equation for predicting y can be expressed as shown on the screen. Other than these methods, there are other measures of analysis of population research. The other measures that may be used for analysis can be association in case of attributes, then there are index numbers which have been widely used these days, then there are time series method and more advanced methods of data analysis. So viewers, you have learnt various methods of population analysis. Depending on the type of population to be analyzed and the requirements of research, we may choose any of the above discussed methods of data analysis. The simple methods of the analysis are the averages, dispersions and measures of relationship. When more than two variables are involved, we may use multiple correlations or regression analysis. So we can say that analysis is an important phase of research on which the interpretation of the results depend, and finally the predictions are made. Therefore, data analysis should be done with utmost care by the researcher. That's all with today's lecture. I hope this must have added to your knowledge. Next time we'll discuss another important topic. Till then, have a nice time. Bye-bye.